Tonight, let us settle in and turn our minds to the heavens, allowing the quiet dark of the evening to wrap around us as we explore one of the most fundamental and deceptively simple questions humans have ever whispered to the night sky. How many stars exist? It is a question that sounds straightforward, yet the answer leads us on a journey so staggering in its scale that it gently challenges everything we think we know about numbers, about magnitude, and about our own quiet place within this vast, breathing existence. Before we can even attempt to grasp the final answer, we must first acknowledge the endearing limitations of our own minds, for we evolved to count members of a tribe or animals in a herd, quantities that rarely exceeded a few dozen, and we never possessed the need to intuitively grasp millions, let alone the billions and trillions that define the cosmos. To understand the stellar census, we must build a ladder of imagination, stepping up from the familiar to the incomprehensible. Consider that counting to 1,000,000 seconds takes only 11 days, a manageable span of time, yet counting to 1,000,000,000 seconds consumes an entire human lifetime of 32 years. And to reach 1,000,000,000,000 seconds, you would have had to begin counting back in the last ice age, before the dawn of civilization, watching empires rise and fall while you steadily ticked off the numbers. When we speak of the universe, even 1,000,000,000,000 becomes a quaint, almost negligible unit of measurement, for we are entering a realm of hundreds of billions of trillions, a scale so immense it becomes almost meditative to contemplate, a numerical ocean in which our intellect can peacefully drift. Let us begin our voyage where humanity always has, with what we can see on a truly dark night, far from city lights, where your unaided eyes might resolve perhaps a few thousand stars, a glittering dust scattered across the velvet black. Yet here is the first profound realization. Every single one of those visible jewels, every constellation that has guided sailors and inspired poets, belongs solely to our own galaxy, the Milky Way. And indeed, they reside only in our immediate cosmic neighborhood, within a few hundred light-years of Earth, meaning that when you look up, you are not seeing the universe in its entirety, but merely the porch lights of our own suburban solar system. The milky band of light itself that stretches across the heavens, that soft, luminous river that gives our galaxy its name, is the combined glow of millions of too distant stars along the disk of our barred spiral home, blending into a collective radiance that speaks to the density of our galactic core, some 26,000 light-years away. For centuries, the universe was a familiar, finite place. It was the dome of stars we could see with our own eyes, a celestial sphere with our Earth at its heart. The Milky Way was a river of light, and the faint, fuzzy patches scattered amongst the stars were mysteries, celestial clouds or nebulae thought to be birthing new suns within our own cosmic neighborhood. This was the known universe, until, that is, our view was sharpened by glass and steel. The great telescopes of the early 20th century pierced this celestial veil. A fierce debate had raged among astronomers. Were these nebulae part of our own galaxy, or were they something far more profound? The answer came from the Andromeda Nebula. By observing a special type of pulsating star within it, a cosmic yardstick, astronomers proved that Andromeda was not a cloud within our galaxy, but an entirely separate island universe, a magnificent galaxy in its own right. It existed millions of light-years across the void, an independent collection of hundreds of billions of suns. This single discovery shattered our perception of home. The Milky Way was not the universe. It was but one solitary galaxy among a multitude. Our sense of scale exploded. But the true census of the cosmos required an even more audacious step. It required us to look away from the bright, obvious galaxies and stare intently into the darkness between them. As our instruments grew more sensitive, culminating in the deep field observations of space telescopes, we took this leap. For hundreds of hours, we pointed our most powerful eye at a patch of sky so small it was like looking at a single grain of sand held at arm's length. And in that sliver of perceived emptiness, we found not nothing, but everything. Thousands upon thousands of distant galaxies, each a pinprick of ancient light, some seen as they were when the universe was just a fraction of its current age. We came to understand the true texture of the cosmos, a glittering, endless tapestry of galaxies. By repeating this profound observation in different directions, we've conducted a grand cosmic census. Based on these deep field surveys, astronomers now estimate that the observable universe, that sphere of existence from which light has had time to reach us since the beginning of time, some 13.8 billion years ago, contains roughly 2 trillion galaxies. 2 trillion, a number so vast it simply defies our everyday comprehension. It is a population of worlds that stretches the very limits of our imagination. And these galaxies are not uniform. They are as diverse as living things. They range from tiny, faint dwarf galaxies with merely a few billion stars, to majestic spirals like our own Milky Way, to gargantuan elliptical giants housing trillions of suns, ancient cities of light that have grown by consuming their smaller neighbours over aeons. But if we're to count the stars, we must find an average. Acknowledging the immense uncertainties inherent in this kind of cosmic arithmetic, we can say that a typical galaxy cradles perhaps 100 billion stars. Now we can perform the final grand multiplication, a calculation that bridges the scale of galaxies to the scale of individual stars. We take our 2 trillion galaxies, and for each one we place 100 billion stars inside. The result is a number that feels less like mathematics and more like an incantation of pure magnitude, approximately 200 billion trillion stars. Written down, it is a 2 followed by 23 zeros. It is a number that represents not just a quantity, but a universe of possibility. To truly begin to feel this number in your mind, let us start with something small and familiar. Picture yourself on a quiet shore at the end of a long, warm day. Imagine the feeling of sand beneath your feet, the countless tiny grains that make up the beach. Now expand that feeling. Think of every beach on Earth, from the great sweeping coastlines of continents to the tiniest, most secluded hidden coves. Imagine the monumental task of gathering every single grain of sand from all of them, a truly astronomical quantity. And yet even this colossal pile of sand falls profoundly short, for there are roughly 10 to 100 times more stars in the observable universe than there are grains of sand on our entire planet. Let that sink in. For every single speck you might brush from your foot after a day at the shore, there are dozens of massive fusion-powered suns burning somewhere in the deep, silent reaches of space. Each grain a universe of stars. Yet even this staggering number, 200 billion trillion, is almost certainly a dramatic undercount. It represents only the stars within our cosmic horizon, the bubble of space whose light has had time to reach us since the dawn of time. It is the limit of what we see, not the limit of what are born. Beyond that boundary, the universe very likely continues, perhaps stretching on infinitely far. If so, it would contain an infinite number of stars, an endless eternal tapestry of matter and energy of which we see only a single, finite, precious fragment. Our entire known cosmos, a mere drop in an ocean without a shore. But let us rest our minds for a moment, not just on the sheer quantity, but on the profound quality of these stars. They are not static, cold points of light. They are dynamic, breathing entities, each with its own life story. Their journey begins in the cold, dark, and surprisingly gentle cradles of molecular gas clouds, vast cosmic structures like the famous Orion Nebula. Here, over millions of years, the patient, persistent force of gravity gently pulls wisps of dust and gas together. As these clumps grow denser, the pressure and temperature at their core begin to climb, until a critical threshold is reached. In a silent, magnificent flash, the nuclear fires of fusion ignite, and a star is born. Once born, they live lives measured in millions, billions, or even trillions of years. Their destinies are written in their mass. They range from the cool, dim, and exceptionally long-lived red dwarfs, which will patiently burn their fuel for so long they will outlive the current age of the universe nearly 1,000 times over, to the brilliant, massive, and impossibly bright blue giants. These titans of the cosmos live fast and die young, burning through their vast reserves of fuel in a cosmic blink of an eye before ending their lives in the most spectacular events in the universe. Supernova explosions. These cataclysms are so powerful they can briefly outshine their entire host galaxy, and in their fiery death throes they seed the cosmos with the heavy elements essential for life. And around these countless suns a new story unfolds, the story of worlds. We now know that planets are not a rarity, but a common, almost inevitable consequence of star formation. Our galaxy alone is thought to be home to hundreds of billions of planets. Many of these will be inhospitable gas giants or frozen rocks, but a significant fraction will orbit within their star's habitable zone, the Goldilocks region, where conditions are just right for liquid water to exist on a planet's surface. While we have not yet found life, the sheer statistical probability is humbling. With billions of potentially habitable worlds in our galaxy alone, and trillions of galaxies beyond, it feels ever more possible that we are not alone. Somewhere on a world we have not yet imagined, another form of consciousness may be looking up at its own night sky, asking the very same questions. In the end, we must always remember that these stars are not merely distant decorative ornaments. They are the very furnaces in which the ingredients of complexity and of us were forged. The carbon in our cells, the fundamental building block of life as we know it, the oxygen we draw with every breath, the iron in our blood that carries it through our bodies, every heavy atom within you was cooked in the core of an ancient star that lived and died long before our own sun was born. We are, in the most literal sense, made of processed stardust. This is not just poetry. It is a profound scientific fact that connects each of us, intimately and personally, to those 200 billion trillion points of light, scattered across the unimaginable depths of time and space. You are a child of the cosmos, carrying the legacy of ancient suns within you. Furthermore, we now know that planet formation is not a rare or special event, but a natural, almost inevitable consequence of star birth. Around nearly every young star we have observed, we see the same beautiful structure, a vast spinning disk of gas and dust, known as a protoplanetary disk. Within these stellar nurseries, a quiet and patient process unfolds over millions of years. Tiny grains of dust and ice, smaller than motes of dust in a sunbeam, gently collide and stick together. Through this slow, persistent dance of accretion, they grow into pebbles, then into boulders, and eventually into planetesimals, the very seeds of new worlds. These coalesce and gravitationally sculpt their surroundings, carving out rings in the disk as they sweep up material, growing ever larger. This process, repeated across the cosmos, suggests the universe is filled with hundreds of billions of trillions of worlds. And on some unknown fraction of these worlds, conditions might be just right. They may orbit their star within the so-called habitable zone, a temperate band, not too close and not too far, where the energy received is gentle enough for liquid water to pool on a rocky surface. And where there is liquid water, there is the potential for life itself to emerge and flourish. This thought brings a profound sense of quiet companionship to the cosmos. While the vast distances between stars may mean we are effectively isolated, living on our own precious island of consciousness, the sheer numbers suggest we are almost certainly not alone in the grand scheme. Imagine for a moment just one of those worlds. A planet bathed in the light of a different sun, with oceans that reflect an alien sky. Perhaps it has 2 moons or 3 that trace silent arcs across its night. Perhaps its life glows with a soft internal luminescence, a biological echo of the starlight from which it was born. The laws of physics and chemistry are universal. The building blocks of life as we know it, carbon, hydrogen, oxygen, are among the most common elements in the cosmos, forged in the hearts of long-dead stars and scattered far and wide. It seems not just possible but probable that somewhere out there, on one of those countless shores, something is stirring. We may never meet, separated by an uncrossable ocean of space and time, but knowing they are likely there changes the character of the sky. The universe feels less like an empty void and more like a quiet, sprawling neighborhood filled with sleeping houses we can only dream of. The universe that contains these worlds is itself a dynamic, evolving place. Nothing is static. Galaxies, those great islands of stars, drift through the void on cosmic currents, and sometimes their paths intersect. Over billions of years, they engage in slow-motion cosmic dances drawn together by gravity. Their graceful spiral arms are pulled and distorted into long, glowing tidal tails of stars and gas. As they collide and merge, vast clouds of hydrogen are compressed, triggering furious new waves of star formation that light up the combined galaxy with the brilliant, transient blue light of massive young stars. This process of creation, however, is not endless. The universe is aging. The overall rate of star birth across the cosmos peaked billions of years ago and is now slowly, steadily declining. The universe is gradually using up its reserves of free-floating gas. And so, as we look toward the very distant future, trillions upon trillions of years from now, we see a different cosmos awaiting. One where the last lights will flicker out, one by one, leaving a cold, dark universe populated only by the cooling stellar remnants of a once brilliant age. Black holes, neutron stars, and cold white dwarfs. But that long, quiet fade is an eternity away. For now, we exist in the universe's glorious stellar era, its vibrant and luminous afternoon. We are alive on a precious, teeming world, orbiting one ordinary, stable yellow dwarf star among a mind-bending multitude. There is a deep and abiding peace to be found in this perspective. It is a humbling realization that while we are physically small and temporally fleeting, creatures of a single moment on a mote of dust, we are also the part of the universe that has awakened to itself. We are stardust that has learned to see. We are capable of constructing telescopes to peer back to the dawn of time, inventing the language of mathematics to quantify the infinite, and possessing the imagination to grasp, however imperfectly, the magnificent scale of the 200 billion trillion suns that share this reality with us. So, as you drift towards sleep tonight, allow this cosmic scale to gently reframe your thoughts. Let your usual worries recede against this backdrop of immense, slow-moving time. Feel them shrink, becoming as small and distant as the farthest galaxies. Rest in the knowledge that you are an integral, conscious part of a majestic, star-filled existence that is vaster, older, and more wondrous than we can possibly imagine. You are a temporary guardian of a spark of cosmic consciousness, and in the silent, peaceful spaces between those countless stars, there is room enough for all our dreams and all our worries to drift peacefully into the quiet of the night.